Okay, we're going to look at section 5.3 here in this tutorial, simplifying radicals. And one thing you have to remember when you're simplifying radicals is what is a radical in simplest form. Well, they give you a good definition in the textbook on page 156. They say that a radical in the form of n power of x, meaning to be in the simplest form, must contain no factor of x other than 1. That is the nth power of it. That means you can't have, if you're trying to find the simplest square root power, you can't have a perfect square underneath the root sign. And there is no radical sign remaining in the denominator, and the radicand isn't the radical underneath the radical sign cannot be a fraction as well. So let's look at some simplified how to simplify radical expressions. Okay, so let's say let's go with a real simple example. Let's say we want to do the square root of let's say 72x cubed y. So what we have to do here is we have to simplify in the sense, well, what is the factors of 72 where we have a perfect square? There's two ways you can do this. You can look for a perfect square that'll go into 72, and then you can take the root of that and bring it out, or you can go right down to the prime factors, which we were doing earlier in the first few sections of 72. Either way works, and I've probably shown you both ways in the notes, and the textbook uses the prime factor method always. So I would say that in this example I'm going to use the prime factor method, and in other examples I'll use my method. So let's go here. This would look like, well, 72 is, simply put, in prime factors, that is 2 times 2 times 2 times, that's 8, right? 3 times 3, which would be 9. 8 times 9 is 72. Okay? And x's, there's 3 x's and 1 y. There's all our prime factors of that number. Okay, so now we have to take out groups of pairs for square root, because there would be a 2 there. So a pair of 2's comes out, a pair of 3's comes out, a pair of x's comes out, and that's it. So what comes out is 2 times 3, which would be 2 times 3 out here, times x. Root, what's still under the root sign? What's not in brackets? 2xy. So simplifying that, this would be 6x root 2xy. And that would be considered the simplest form of a radical expression. Now the other way to do it is you could have took this and said this 72 is the same as 36 times 2, and then when you took the root of 36, you would have a 6 out here, and the 2 would still stay underneath the root sign because you can't simplify it it's not a perfect square. And then of course you could have took out 1x squared for an x, and then 1 would have been left underneath, and you couldn't take any y's out. So that was the alternative method. So let's take a look at a few more examples here in this section. So B, let's say we have something that has square root of the fraction, let's say 16 over 15. Okay, so in order to do this method, it's a bit more tricky than just simplifying as we did here. So this would be, in terms of prime factors, square root of 16 would be 2 times 2 times 2 times 2 over 15 is just 3 times 5. Well, we cannot simplify the bottom numbers here to get an even, because we have a 3 and a 5. So one of the methods that you can use here is, well, we need pairs of 3's on the bottom, and we want to get rid of the denominator. So we can put a 3 in there. If we put an extra 3 in there, we have to put an extra 3 up here. Do the same for the 5. Put an extra 5 down there. If we put an extra 5 down there, we have to put an extra 5 up here. So now we can reduce this by taking pairs out. So we have a pair here and a pair, well, a pair of 3's and a pair of 5's. Excuse me, I didn't write them close together. So these pair of 5's is together and this pair of 3's is together. And we have a pair here and a pair here. So let's write that out now under the radical sign. So here we have 2 times 2. Oops, I have to bring them out. 2 times 2, almost made a mistake myself. Then the 3 and the 5 stay underneath the radical sign from the top. Ignore my almost mistake there. And then we can take out a 3 and a 5 down here on the bottom. And this just leaves a 1 here underneath the radical sign. So then this becomes 4 over 15 root 15 over. And that would be another way you could write that. You could say 4 root 15 over 15. Those would be the same answers in that case. Let me just check my field of view, make sure that that's in there for you. Okay, I think I've got enough time to do one more example here. With some letters in it. Let's say we had, let's use a cube root this time. We haven't used a cube root for a while. Say we had cube root of, let's say 10x to the power of 4 over, let's say this was just 3y to the power of 2. This is all under the radical sign. So if we have to simplify that similarly as we did last time, we could say that this is the cube root of 10 is 2 times 5 with 4 x's. And we have 3 with 2 y's. Okay, so if we want groups of, we want to take on the bottom here and make sure we have 3 3's. So we have to add 2 3's on the bottom to get 3 3's. We add 2 3's there, we add 2 3's here. And we have to add a y on the bottom to get 3 there and a y there. So now let's take our groupings out. Well, we know what the bottom is going to be, a 3y on the bottom. So we can just write 3y out here. And we can take out an x on the top. And I think that is it, because there's nothing else that we can group up. So we have 5 times 2, which is 10, times 3 times 3. So that's 10, 30 times 3 is 90. This is the cube root. X, which would have been left because we cancel 3 of them out, y. And that is our answer. Another way you can write that is x cube root 90 xy over 3y. Okay, and that's our examples for section 5.3. And we'll go on to our next section. We'll be looking specifically at adding and subtracting using the same property, but going along and adding and subtracting, multiplying and dividing as well.